This lecture introduces the news window model, but the focus is how to construct the demand model for the news window problem and how to evaluate the performance measures for your news window decisions. So in the lecture time, I have been too busy to talk about different things. So here in the video, I try to repeat what we have gone through in the lecture. So first, we start with an example. So this is a fashion designer, or it's actually white suits manufacturer. O'Neill, this company, they produce the white suits and accessories for water sports, and they have 2 selling seasons, and then they call the spring season or autumn season. And 3 months production lead time. So this is the time before the products can be delivered to the retailer. And this company faces to the considerable demand uncertainties. So it's a rather large sigma values. So how many units of a product to order from the manufacturing in Mexico? So here we focus on this specific product, Hammer 3 or 2. This is the event list of this inventory decision making problem. So first, the selling season starts from the beginning of February, and then there are 3 months lead time. So here called lead time. So then beginning of November of the year before, so they need to generate forecast and submit an order to the manufacturer in Mexico. And the selling season is 6 months. And then from beginning of August, basically the end of summer, then this product's leftover inventory will be discounted or marked down. So the question is how many units you should order from the manufacturer. News window model might not be new for you. Here we just re-clarify the steps. So if you decided to use a news window model to handle your problem, your inventory decision problem, then normally you need to go through 4 steps. You first need to generate a demand model. So determine a distribution function that accurately reflects the possible demand outcomes. For example, we can have a normal distribution function. And then that means you need to have a mean or standard deviation for your demand distribution. Then you need to gather economic inputs for your news window model. So you need to know the selling price and purchasing costs and salvage value. Salvage value is discounted price. And choose an objective. So you can choose to first maximize expected profit, or you can choose to satisfy a targeted in-stock probability. So that's actually different objectives. It's up to the situation. And then choose a quantity to order. So that's a final decision. The next, we try to go through each step. First, we need to construct a demand model for the problem. So then what is a demand model? So here we're talking about possible probability distribution for your demand. For example, if your demand is a normal distribution, for example here in the dark blue curve, you can see you have actually almost a mean of average with 100 units, and then you have actually the standard deviation specified. So the most of the time your demand will be the range in a small area, and then you also have a risk to have a very low or very high demand. But you can see when your demand is very high, then the probability is actually small, and when your demand is very low, so here the probability is actually also low. So it's a very low demand and a very high demand. And so this probability distribution can actually describe the real-world market conditions very well. That's also why the normal distribution is commonly used as a demand model for the news window problems. And then if your average demand is very low, for example less than 20 units in average, then you can consider to do a Poisson distribution. So Poisson distribution performs good for the discrete distributions and single parameters. We talk about how to handle the Poisson distribution demand functions in the next lecture. Before we talk about the news window solutions, we take some time to actually clarify the distribution and the density functions, particularly for the normal distributions. I do not go through the text. We use the distribution function figures or graph to explain it. So here we have two graphs. The right-hand side graph actually shows the probability of your random variable value is less than or equals to a value. So this is basically the meaning of this curve. And then in another way, we actually name this distribution function value as fq. So this is a probability. For example, we can see if your q is 100, then the probability of this demand distribution value is less than or equals to 100 units will be around here, let me see, 45%. So we can see here, if we extend that, then we have f. We have a probability of d less than or equals to 100 equals to f100 equals to a normal distribution with a parameter of 100, and you need to know average, mean, and the sigma. So here we have a cumulative function. So try to correct it. Then we have a cumulative value. In this graph, we can just rate this value is about 45%. And then on the left-hand side, this is a density function. Basically, this is a probability of your random value equals to the specific value. For example, the probability, the demand will be Q exactly. So this actually is the value here. For example, we can see the value for QD equals to 100. The probability is here. So that's actually density functions. They mainly shows the probability of your value is like greater or smaller. So you can see in the most of the time your demand is in the range, smaller range, but when your demand is extremely low or extremely high, actually the probability is small. We actually do not really use a lot for the density function, but the most important part is we need to understand the accumulative distribution function. So we can just highlight this graph. Now we see a little bit more details about normal distribution. So now you can see all normal distributions are characterized by two parameters, mean and standard deviation. So that's common knowledge probably. And all normal distributions are related to the standard normal that has mean 0 and a standard deviation 1. So if we see the normal distribution is normal, mu, and standard deviation, then your standard normal distribution can be written as a standard normal distribution with a mean 0 and a standard deviation of 1. So normally we say if your demand is a normal distribution of mu and the sigma square, and then we can transform the demand into a standard normal distribution, standard normal distribution. So for example, let Q be some quantity, and mu and sigma is parameters of normal distribution used to model the demand, and the probability demand is Q or lower. So if we transform this sentence, that means your demand is less than or equals to Q and equals to the probability, the outcome of a standard normal is actually zeta or lower. So you actually probably need a capital zeta and then less than or equals to a small zeta. So in that thing, we need to actually transform the normal distribution or normal demand distribution into a standard normal distribution. So the idea is for any value of Q, and the Q can be transformed into a small value zeta. So that means you have a Q, and then you can actually find the zeta based on the parameter mu and sigma. So we actually have Q equals to mu plus zeta times sigma. So then the question turned into, so if you initially would like to decide a value of order quantity Q, now you actually can transform your problem into find a critical value zeta for your decisions. So that's basically equal Q actually equal to the decision of zeta. And how to find the value of zeta? Normally we need to use a standard normal distribution function table, but it's not necessary we always use a table. That's somehow old-fashioned. So the idea is now if you know the small zeta value, you can use the Excel function. So this is an Excel function, and you can find the probability. So the outcome of standard normal is zeta or lower. So if you use a function, then the value is phi zeta. That's what we normally use. So phi zeta equals to actually FQ. So that's actually the implicated relations. So here is how to read the standard normal distribution function table. So if you know the zeta value from your order quantities, then you can find the probability. So this is often used to find the, for example, in-stock probability or out of stock or stock out probability. So here, for example, if you want to find the values of zeta, then the idea is to read from the column from, for example, it's a 0.2, and in the horizontal height you read a value 0.002, then you actually point out now zeta equals to 0.22. Basically is 0.2 plus 0.02. That's how you use a column height and the row height. And then if you find this value on this cross, So basically you find the probability. So that means phi zeta equals to 0.5871. And then that's how you use this table. So we probably have an example for the inverse function. So here is an example. You try to find the value zeta equals to 0.28. Then the idea is to find the 0.8 in the vertical column, Z column, and then find 0.08 in the horizontal column head. Then you find the value of probability. So here that's how you find the probability of 61.03%. That's basically just how you rate this table. The good thing to use a normal distribution function table is you can actually see basically what you are looking for and what's the result you get. If you use Excel functions that need you to understand all these mathematical functions f and phi, so just the different level of the applications. Then we continue with this example. Let's see the question, how to start with a probability and find the corresponding quantity. So that means if you have a probability 70.19% chance, and outcome or standard normal will be that zeta or smaller. So basically you have a function zeta equals to 1719. That's a pre-known information. Now the questions we would like to know what is the value of z. So the method is to find the probability. So we find this probability in the table 0.7019, and then corresponding to the row and the column head, and then you find the value 0.5 and 0.03, then you find that the zeta value is 0.53. As I mentioned before, if you think it's too trivial to use a table, then you can always use the functions in Excel if you understand which function to use and how to realize this transformation from probability to the order quantity, from order quantity to the probability. So here we can see for the first question we have done, what's the probability that the outcome or standard normal will be zeta equals to 0.28 or smaller. So basically we're interested in the value phi 0.28 or probability of your d minus mu divided by sigma less than or equals to zeta. So actually not necessary for you to go through all the mathematical derivations. So you just remember, if you know the critical value of zeta, then you can directly use a normal distribution function to find the probability. So this, for example, is a in-stock probability, or stock out probability is up to the question. So in order to use a Nussweiler model, that's very important you understand the normal distribution very well. So here are several exercises, so I suggest you to try them out. So these are the answers I did in the Excel workbook. So of course you can also try them in the distribution table. It's up to what you're most familiar with. So we have spent quite some time to explain what is normal distribution, but actually our initial purpose is to find the demand model for your problem before you can use a Nussweiler model. So how to actually generate your demand model, we come back to the initial question. So if you know the historical forecast in your company. So we are talking about here forecast performance. So we actually plot first your actual demand and forecast values in the coordinate system. Now you can see if your actual demand equals to forecast, then it should always be in this diagonal line. But from the plot you can see at some time your actual demand actually greater than forecasts, and in some situations you actually have the actual less than forecast. So that means you need to know about your forecast accuracy in your company. Then you can actually adjust your demand forecast in order to generate the more accurate demand model. So this graph shows all these surf white suits sales from previous seasons. So that's also the common practices if you know the previous season's sales for similar products. So here we just see the surf white suits, but they may be different from Hammer 3 or 2. But the requirement is all these surf white suits should have a similar sales performance or situations. So since Hammer 3.2 is a new design, and then you do not have historical sales for these products, so in the fashion industries that's very common. You use actually similar products. So if we see this here, all these products are similar or relevant products to your Hammer 3.2, and then you should have the historical records for the forecasts and actual demand. So actual demand, this actually normally the company have the historical sales information directly, but it's not necessary all the companies keep the information for the historical forecasts. But here in the textbook you probably also read, we emphasize as very important, so the company should keep their forecast history, and then you can actually reuse your forecast tendency or the performance to adjust your future forecasts. For example, in this example, you have actually multiple similar items, and then if you work on a AF ratio, so that's actual demand between the ratio between actual demand and the forecast. And then you got all this performance. For some items, you actually have a very high, for example, very high ratio. So that means actual demand is quite high, greater than your forecast. In some situations, for example, here we have a Zen zip. You actually have a very low ratio. That means your actual demand actually a lot smaller than your forecast. How can we actually use this AF ratio to generate your own demand model? Let's see the next slide. So we actually introduce this method called using historical AF ratio to choose a normal distribution for the demand model. In this case, in the O'Neill's, his company's example for Hammer 302, and then the forecast. So this actually is the forecasting. The forecasting for this product is 300 to 3,200 units in the next selling season, and then next step you evaluate AF ratios. So you get actually all these AF ratios for historical data. Here we're talking about multiple comparable or similar items. quite unlikely you have exactly same. Then set the mean of the demand normal distribution to expected actual demand equals to expected AF ratio times forecast. So that means you need to actually calculate average AF ratio times your forecast. You will get actually a more accurate forecast. So this actually expected actual demand is just expectations, but here we actually still think this is the mean, more accurate mean of your demand. Another result from this method is we can set the standard deviation of the normal distribution to the standard deviation of the AF ratios times your forecast. So you actually can see from AF ratios, you actually can see the actual demand actually fluctuate a lot from your forecast. That means there are actually large variance in your demand forecast. So you should consider this variance. So after we have done this, then you find a mu, and then you find a sigma, so that now you got a normal distribution for your demand. So demand now is a normal distribution with a mean and a sigma. So now we summarize the method for the example HAMR 3.2. Then now you can see average AF ratio is 99.75 and average forecast is 320. Then you can calculate the new mean. So this is mu equals to 392. And the standard deviation is a standard deviation of your AF ratio times your forecast. And then you get a sigma equals to 111. So now you have a normal distribution for this HAMR 3.2 distribution with a mean of 3092 and the standard deviation is 1181. So the next the continued discussion of this lecture will be based on this specific normal distribution.